let's talk about scalar and vector quantities. Scalar quantities involve magnitude only, while vector involves both magnitude and direction. Now, what do we mean by magnitude? By magnitude, we mean that it involves a quantity, value. For example, 5 meters, 6 kilometers, or maybe 7 meters per second. Those are examples of magnitude. And in scalar, there are two quantities that we're going to talk about today. That is the speed, distance. Speed and distance. Now, let's talk about distance first. By or distance is basically the total path traveled, total measure of the path traveled by an object. For example, Bob is in point A. Point A to point B is about 50 meters. Bob travels from point A to point B. What is the distance traveled? 50 meters. Now Bob travels back to point A. Now how much distance? What is the distance traveled by Bob in total? That is 100 meters. So distance is just the total path or total measure of the path traveled by an object. Now, let's talk about speed. Speed is another scalar quantity. It involves the relation of the distance traveled to the time. Speed has a formula of distance over time. It means that we mean so speed is just the correlation between distance and time. So speed has the formula of distance over time. So for example, Bob travels a distance of 50 kilometers in 2 hours. So according to our formula, distance over time, we divide 50 kilometers by 2 hours. So 50 divided by 2 is about 25. So 25 kilometers per second. So that is how you get the speed of an object. So the counterpart of scalar quantities is the vector quantities. Vector quantities involve magnitude and direction. So for example, 5 meters to the north, 6 kilometers to the south. That is example of vectors. Now, again, we're going to talk about two vector quantities. First one is the counterpart of distance, which is displacement. Displacement is a little different than distance. So we talk about the distance as a total measure of the path traveled. Well, so displacement is the straight or the shortest, the absolute value of the distance between point A to point B in a straight line. So for example, point A point B. So there's a road going west. Okay, we have a compass here and east. Okay, going to the west, then going to the north. So it's about northwest. So this is 50 kilometers and this is 20 kilometers. So when we talk about distance, it's gonna be from here to there. We add them up, so it's 70 kilometers. That's for the distance. But for displacement, it is the straight or the measure of a straight path connecting the initial position and the final position of an object. So from point A to point B, this is the straight path, which we will get displacement by calculating the measure of that straight path. So by using trigonometry, so this forms a right triangle. This is the hypotenuse. So by using the Pythagorean theorem, which was a squared plus b squared is equals to c squared, we substitute the values and we get the number or the measure of the straight path connecting final position and the initial position of an object, and that is displacement. So for example, we're not going to use the value given. For example, the total distance of this straight path is about, say, 70 or yeah, 70 kilometers. So instead of actually adding these up, so instead of actually adding up the distance traveled, displacement is just the shortest path or the straight line connecting the initial and the final position. It's about how far the final position is from the initial position without correlating it to paths taken, distance traveled. It's about how far. So you need the absolute value of it. So that is displacement. And it involves direction. So direction of it is about northwest. So 70 kilometers to the northwest. That is the displacement of the object. It's in the word displacement. How or what is the measure of the displacement or the changing of position of an object? Its initial and the final position. So that is displacement. It's the difference between distance and displacement. Okay, now we are going to talk about the counterpart of speed, which is velocity. Velocity. Velocity is a simple, it's more simple compared to that of the relation between the distance and displacement. Speed and velocity is basically the same, except that velocity just has a distance, or I mean a direction. So the speed is, for example, the speed is 10 kilometers per hour. That is the speed. So the counterpart or the vector should always just be, or it should always have a direction. So to the north. That is just the difference between vector and speed. So, but if you have to memorize a lot and you need to memorize or to distinctify between speed and velocity, just remember S. Speed is scalar. SS. While velocity is vector. VV. It's the same first letters. And for distance and displacement, to sum it up, distance, it's a total path traveled. Displacement is just how far the initial position, the starting position, is from the final position. Speed is the relationship between distance and time. So the formula is distance over time. How far did you travel in a certain amount of time? That is speed. And the counterpart of speed, which is velocity, is basically speed with direction. So that is all for now. Scalar and vector quantities. For more science knowledge, subscribe if you want and like the video. It helps me a lot. It helps me a lot. PhysicSci signing off.